We're going to talk about functions in this unit in Oracle, and it's similar to other programming languages perhaps where you've used functions. So it's not unlike something like Java or any other programming language. And specifically in this unit we talk about row-level functions, so functions that only affect or that can affect just a single scalar variable. We'll talk about other types of functions later on in the next unit, in fact. And we also break it down into basically 4 categories of functions. There's character functions, which are designed to do things with strings, like string functions that you might find in other languages. There's also numeric functions, date functions, and we'll also talk about regex, or regular expressions functions, which are a special set of functions. Some of these functions you can use across different data types, and I'll talk about that a little bit as we go through these. So first, let's start with the basic syntax for using functions, and we kind of did this already. We used the upper and lower function in another unit, among a few other functions we may have touched on here and there. But basically, whether you're using the function in the select clause or the where clause, you use the function name followed by the arguments in parentheses. And typically those arguments will include column names. So, a lot of times you're passing the column name into the function along with some arguments to do things with that column name, which we're going to talk about here in this presentation. So, for example, let's say I had a table that had last name and first name in 2 different columns, and you can see here it's a mixed case, capital letter, lowercase letters for the rest of the name, what we call title case. Pretty basic table. But let's say I wanted to return that table in all uppercase. So you would use the upper function, and I can do that right in the select clause. So then my table would look more like this, where I see the uppercase letters. And likewise, we could use lower. So then my table is all lowercase letters. And finally, another case function we can use is initCap, which will set title case. So it'll capitalize the first letter of each word. So for example, in this case, it would look like this. You can see all the names, the first letters capitalized. So we're right back where we started with the mixed case, with the initCap function. So let's say you wanted to do a search on this table, and you weren't sure how all the data was entered. Some of it might be all lower, some might be all uppercase. Who knows? It's all different case. Maybe it's dirty data. So you want to use a where clause to convert everything to upper. But the cool thing about this is I can both select with the initCap function, and I can do my where clause based on all uppercase. So that way, the presentation of each column doesn't affect how we're searching on each column. So we can still take the value of the field we're looking for, convert it to upper for our where clause, but when it returns the results, it's still going to do it in mixed case, or in this case, initCap. So the next function is Substring. So every programming language pretty much has a lot of these string functions that we're going to talk about. Substring is no different. It's in almost every language that you'll learn. And we'll use the typical hello world to demonstrate this. But let's say, and first I'll explain what the substring does. The substring basically allows you to pull out of a string or out of a character field just certain words, letters, or just a certain contiguous block of characters from within the string. So for example, if we wanted to just get the word world out of hello world, we could do that with substring. We basically start, when we write this function, and the arguments that you see, character is the whole string that you want to pull a word out of. Begin index is where you want to start, and the length is where to end. So we have to tell it where to start, and we do that by counting the letters. So if I were going to do that with this word, I would say, okay, H is letter number 1, 2, 3, 4, 5, 6. So letter number 7, which is the W, is where I want to start. That's going to be my begin index, number 7. Then I would count my length. So my length is 1 for W, 2, 3, 4, 5. So we have 5. So when I write my function, it's going to be hello world, comma 6, because I want to start at character 6, which will be the W, and then comma 5, because I want to count 5 characters. And that'll return hello world. So the next thing we can do is an in-string. In-string is where we can search for a certain contiguous characters within a string. The arguments are, you can see I put the arguments here. I put it a little different than the book, but we start with the haystack. The haystack is the entire string. Needle is the string that we're searching for within the haystack. Then we can tell it where to start our search and the occurrence number to start from. So if you're looking for a specific string of characters within the character field, you would put that in needle. The entire field goes into haystack. Optionally, you can tell it where you want to start. You can start from the beginning, which is the default. So if you don't provide a start, it's going to start at the beginning. Or you could tell it skip the first 3 occurrences of this character or this symbol or whatever it is, and then it'll start from a future occurrence. So you can use all of those different options. Typically, I see the in-string 2 ways that I would use it. One, if I'm checking to see if a field has a certain value in it, or if I want to do a substring function. So before, when I did my substring function, let's say I was doing a substring function on this email address. I want to pull out just the domain on the email, so just the part that says Drexel. I would do that with something that looks like this. Substring, let's say the field name was email in the database, comma 7, they count 7 to the D, and then comma 6 because it's 6 characters in Drexel. But every email address is not going to look like that. Although Drexel's a bad example because I think probably 90% of our email addresses probably look like, would work with this function. But in the real world, email addresses can look like anything. So we want to make sure that we write our little function or write our select statement so it would work on any email address. So the first thing is, instead of just putting the 7 there for the start, I want to dynamically start that substring. And I want to do that based on where the @ symbol is. So instead of doing 7, I could just say, find me the @ symbol. Which character is the @ symbol in the string, dynamically? Now, in this case, it's going to return 6. We know we don't want 6 because we always want 1 character ahead of the @ symbol because we want to start in front of the @ symbol. We typically don't want to return the @ symbol if we just want that domain name. So I'm going to add 1. So by adding 1, it's going to give me the string that I want, that letter D. So the next argument is 6, which is the which for in-string, or I'm sorry, the next character is 6, which for substring is how far to count. Now I know in this case I want to go 6, but how am I going to figure that out dynamically with the string? Well, I know that there's always going to be a period after the domain, just before the top level domain, the TLD on the end. So I know between the @ symbol and the period is what I want. So if I find the position of the period and subtract it from the position of the @ symbol, that should give me what I need. So I'm going to do that. I'm going to do in-string email, look for the period, then I'm going to subtract that from where the @ symbol is. So period minus @ symbol. And that gives me that position. Now, it's not quite right yet because while the front is starting on 6, we have that in place. It's going to stop at that period, so it's going to include the period because the count's going to be 7 instead of 6. So just like before, I had to add 1 to the @ symbol. For the period, I have to subtract 1 to come back to the letter L. So now it's going to look like this. You can see I subtracted 1 within that substring function, and that should work. So if I do this right, it should give me 7 for that D, and it should end on that 1. So it should just return Drexel. And this is what you should see when you do a select on a field that contains that email address, or really any email address. Well, maybe not any email address. What if the email address looked like this, brian.green@iee.org? There's a period in my username, which is perfectly valid in an email address. So if I use the same function that I wrote with substring, using the in-string function, it would not work. It would return a blank string because the period, that first dot after Brian, is going to be less than the @ symbol. I'm going to have a negative number, and I can't pass substring a negative number. It's not going to give me what I want. Different languages handle these negative numbers different ways, but in Oracle, you're just going to get a null string. So the way to handle this, I can just add 1 little bit of code into that substring function to say, instead of giving me just the first period that you find, don't start looking for periods until after the @ symbol. So in that in-string function, I'm telling it to start at the position of the first @ symbol. So I've actually nested in-string inside that in-string function. which is perfectly valid. You can nest these functions, and you'll find that in the in industry that you'll have lots of nested functions doing all kinds of crazy things. And we're going to talk about in the next semester, the next quarter, we talk about how to do this a little bit cleaner. If you find yourself writing these huge functions to transform and manipulate data in a select statement, sometimes it makes sense to write your own function, which we'll learn how to do in the next semester. So the length function gives you the length of a string, or the length of really anything. But although with some data types they would only have one valid length. But in any event, when you use the length function, it'll give you the length of the string. So if I did it in this case, if I do select length last name, length first name, it's going to give me just the lengths of each one of those fields. So you can see there's my lengths of each field. I should mention here that I'm doing a select from the table name looks a little different here. We're selecting from a table called dual, which you should probably saw in some of the previous slides. The dual is a special table in Oracle that lets you select from nothing. So it's basically an imaginary table that you can select from to try these functions. It's not widely used in production. You ordinarily wouldn't be using dual in production. It's really a great way to test functions and to test things that would happen in the select clause without actually selecting any real data. So that's why I'm using it here, because we're just kind of showing samples of things. So if you decide to try some of these functions on your own, you're going to probably want to use the dual table and just use static strings rather than having to create a table, populate the table, and then use that to do your testing with your functions, or trying these functions. So LPAD is if you wanted to pad, and by the way, LPAD is the left pad. There's also a right pad. So there's an LPAD and an RPAD. Padding is basically where you take a string or a character and you either stack them up on the front or the back side of a string or a character. So for example, if you look at my table here, let's say the ID for all of these people, it's a single digit in this table, but let's say the users tell you, hey, we're not used to seeing single digit IDs. All of our IDs are always 9 characters. And as hard as you might try to say, well, 000000001 is the same as 1, why does it even matter? Users can be funny about that stuff. So let's say you had to put zeros, leading zeros on these IDs. You could do so in the select by doing LPAD, then the ID is the field, so that's the string that you're passing into the function. The padded character is a 0, and the length of the whole field should be 9. So it's going to make sure that that field is always 9 characters. So after this select, my table would look like this. So a whole bunch of leading zeros. Looks funny, but that's one use case for the for LPAD. LTrim is sort of the opposite of LPAD, and just like LPAD, there's a left version and a right version, so LTrim and RTrim, and that basically takes off any characters from the front or the back of your string. So to call this, you pass in the field that you want to trim and the character you want to trim from that field. So in this case, I'm going to trim all the zeros. So by passing 0 into LTrim, it's going to find any zeros that are on the left side of the string, and it's going to trim them all back until it runs out of zeros to trim. So in this case, we're right back to what we had before. So this might be the opposite problem. Maybe you've got a database table with a whole bunch of records with leading zeros on an identifier, but you don't want those leading zeros to display in the interface, so you might use this function to suppress those leading zeros, or any other field. It could be spaces, it could be underscores, all kinds of characters, asterisks, ampersands. People do funny things with data sometimes for formatting, so you could manipulate that stuff on the fly with these functions. Replace lets you find a string or a character within a string and replace it with something else. So for example, if I have phone numbers with dashes, somebody might say, hey, when we select that information into some other system, we can't have the dashes, it breaks the formatting rules, so we just need just the numbers, no dashes. So you could do that with the replace function. So I'm going to say select all the phone numbers into the replace function and find any dashes, replace it with a blank string. So then I end up with phone numbers with no dashes, as you see here in the example. Concat lets us put fields together. So in my example, again, I've got a last name and a first name in two different columns, which is okay, but most users would probably want to see that formatted as maybe last name, comma, first name. So using the concat function, I can select both of those commas, or both of those fields rather, columns into one field. In this case, it's not exactly what we're looking for because it's going to kind of push everything together. There's not going to be a space between the two or a comma. So it just says, for example, the first one, Babbage Charles, but no space, no comma. In other database engines, you can use the concat function with you can keep concatenating things to one column, which is great, but Oracle doesn't let us do that. So the only way I know to do this in Oracle with the concat function is to do it multiple times. So inside the function, I'm concatenating the last name field to a comma followed by a space. So that's going to give me last name, comma, space. Then I'm concatenating that whole thing to the first name with the outer function. And that will give me the result I'm looking for, which is last name, comma, first name. There are other ways to do this, but with the concat function, this is how you might do that. Next, we're going to talk about numeric functions. So these are functions that are mostly designed for working with numbers. So our first example is round. Pretty basic function. You pass it a number and the position to round to. So for example, let's say we have this number 1928.9175. And if I wanted to round that number, first you have to figure out what digit do you want to round to. So a positive number, so if P is passed in as a positive number, that's going to be on the right side of the decimal point. If it's a negative number, it's to the left of the decimal point. So as an example, if I wanted to round this to just a round number with no decimals, I could just do 0. And 0 tells me, just give me what's on the left side of the decimal point. So in this case, that would be 1929, because it's going to round it up, because after the decimal is a 0.9. If I wanted to round it to the nearest tenths, so it should round to 1930. So if I want to round to 1930, I pass a -1. And that gives me what I'm looking for, which is 1930. And I could keep going. I could go to 2. So there's my 2. My second character is the 9, so it's going to round to that digit. And there it is, 1900. The way I remember the negative numbers, this is the way I remember it, is the number of the negative number is the number of zeros that I'm going to have after rounding. So that's how I always remember it. So if it's -2, I'm going to have 2 zeros. If it's -1, I'm going to have 1 zero. If it's 0, I'm going to have no zeros. If it's -15, I'm going to have 15 zeros in my number. So that's how I remember how to do the rounding with the negatives. With the positives, it's a little more straightforward. If you want to the first decimal place, you use a 1. To the second decimal place, a 2. To the third one, a 3, and so forth and so on. So in this case, if I do a 1, it's going to round to 1928.9. If I want to round it to 2, which would be like money, if I was rounding for, if this was dollars and cents, this would probably be how I would do the round. I would do round number, comma 2, and it would give me 1928 and 92 cents. The next one is truncate, or trunk for truncate, which is similar to round, except it just chops the number off. So it's not going to round up or round down, it's just going to chop it off wherever you tell it to chop it off. But the arguments are the same. So using the same number, I have the same notation for how to tell it which number to truncate from. But this time I'm not going to have zeros. It's just going to truncate at that position. Well, I will have zeros, but it's not going to round something up or down. So, for example, before when I used 0, it rounded 1928 to 1929 because it was 0.9. But you can see in this case it goes to just 1928. It just cuts it off. It just cuts the decimals off and leaves it where it is at 1928. Likewise, if I go to -1, I'm going to have 1, 0. Again, same way. I remember this the same way. I've got, if it's -1, it's 1, 0. -2 is 2 zeros, and so forth. So it just cuts it off to 1920. It didn't go to 1930 like it did before. And likewise, I can go to 2, which will give me 1900. And I can go the other way, down to the decimal points. So I have 1928.9 and 1928.91, which before was 0.92. So truncate just chops off everything to the right of wherever you're truncating. ABS is absolute value, so that basically gives us the positive equivalent of a negative number. The number of, I always think of absolute value as the distance from 0, whether it's negative or positive. So for example, if I have a number -523.5 and I pass that in, and absolute value only has one argument, it's the integer that you want to, or decimal that you want to get the absolute value of, it's just going to give you the positive version. So it'll basically like multiplying times times -1 in this case, but it'll turn the negative into a positive. We have 523.5 for the absolute value. We can also take numbers to a power. This is the last numeric function that I'll show you. There are many more numeric functions that you can play with. Our book talks about a few more that I perhaps didn't cover here, but there are lots of other ones, and of course Google is your friend. You can search all these. There's no shortage of documentation for numeric functions or even string functions for Oracle. But in any event, we can do a power of something. So x is the number, is the base number. Y is what you want to raise it to the power of. So real basic example, 2 to the 0 is going to give us 1. 2 to the 1 is going to give us a 2. 2 to the 2 is going to give us 4. 2 to the 3 is going to give us 8, and so forth and so on. We can go to 16, 32, 64, 128, and so on. So that's how you raise to a power with the power function. Now we move into dates. So I'm going to show you some things with date functions. Let's start with months between. So months between is pretty useful because here's the thing about dates. On the surface, it seems like dates should be simple, and I think a lot of programmers, when they start out thinking, well, this shouldn't be too hard doing dates, adding dates, subtracting dates, but it's a lot harder than it seems like. It's there's a lot of weird things about our calendar. Not every month has the same number of days. Even different years have different number of days because of leap years. I mean, it's all, you can figure it all out, but it's definitely a lot of stuff that you have to worry about when you're writing functions to deal with dates if you're doing it yourself. So most programming languages, and Oracle is no exception, gives us some functions to deal with dates and to add and subtract dates and to work with dates, so that we don't have to deal with the minutiae of having to figure out how to manipulate dates and worry about all that stuff. So let's take a look at an example. If I have two dates, the 1st of December in 1999 and the 1st of October 2002, if I want to find out how many months there are between those two dates, I feed those two into the month between function, and it's going to give me the answer, which in this case is -34. Now this is important with these functions, with date functions. Sometimes you get a negative number. Now if I reverse that, if I had 1st of October 2002, comma 1st of December 1999, I would have had a positive 34. But most of the time it doesn't matter whether we get negative or positive. I mean, usually we don't care. We just want to see a positive number. How many are between these two dates? We don't really care if it's, backwards or forwards. So we already learned how to convert -34 into positive 34. We simply wrap our months between function with the absolute value function. So we just make a little function burrito here and put the absolute value around the months between, and that will give us what we're looking for, which is 34. Now likewise, I could change, so I just made a little change in that function. Instead of the 1st of October, I set it to the 15th of October. Now you and I both know that that should be around 34.5 months, so roughly 34.5 months. But computers, as you know, are a little more exact than that. So the computer is going to tell us it's 34.4516129. So that's the separation. Now, normally we probably wouldn't want to write it that way. That's way too many digits. So in the discussion forum, you can certainly post how you would basically write this function so that you have something more readable, something that would make more sense to display to a user. You certainly want to tell them that that the 15th of October is 34.4516129 months from now. That wouldn't make much sense to most people. We can add months to an existing date. On the surface, this sounds easy. If I have the 31st of October, 2012, and I add 8 months to that, it should put me into June. And normally you would say, oh, okay, well that's going to be June 31st, 2013. And then you realize, wait a minute, June doesn't have 31 days; it only has 30 days. So you can't simply just take the 12 and add an 8 to it. You would think that maybe I could do that, but let's say we have a date, and we want to find the next day of the week, the date of the next particular day of the week for that date, the date that's going to occur on that day of the week. So, for example, maybe we ship all of our orders on Thursdays. Today is June 1st, and our order is going to ship the next Thursday. We want to get that date to display to a user. Here's the date that your order is going to ship. So in that example, we use the next day function. You would pass in the date, and then the day of the week that you're looking for. That is the occurrence of that day. What's going to be the date after the current date? So in this case, if it's June 1st, Thursday is going to be June 4th. So a nice little function that gives us an easy way to find the date of some day in the future. But it's always the next occurring day. Another one, sort of in the same category as next day is last day, and that's going to give us the last day of the month. So if we pass a month in this case, let's say I put in a date that's the 2nd of February 2012, and I want to know what's the last day of the month for that date, for that particular date. Well, 2012 is a leap year, so Oracle is smart enough to know that, and it tells us that the 29th of February will be the last day of the year. And of course, it's also smart enough to know that 2013 was not a leap year, so it would tell us that the 28th of February will be the last day of the month for that date. We can also do some date formatting. So let's say I've got a date that was entered by a user into a user interface. Users usually don't enter dates in the format that Oracle uses, which is, normally you and I wouldn't write a date on a formal letter to somebody as 12-May-13. That most people don't really use dates in that format. And most other database engines use other date formats, like the ANSI date format, which is today an ANSI format would be 2013-05-12, something like that. So to get around that, you can take a date and format it to the Oracle date format. So the way we do that, let's say we have this date, July 4th, 2005. And if I wanted to convert that to Oracle format, first I have to tell Oracle what is the format, what's in each position here. So July is the month, 4 is the day, 2005 is the year in 4-digit format. Those codes, or that mnemonic that you see there, month, DD, YYYY, they're in a table in the textbook. They're in tables everywhere on the internet. There's no shortage of them. You can find them if you Google them, or Yahoo or Bing or whatever you like to use. But in any event, they're well documented. There's a lot of different options. So for example, the ANSI standard, I would put YYYY-DD- MM-DD to give me the month in numeric format. So lots of different options there. But when you pass that toDate function, your unformatted date, which in this case is July 4th, 2005, pass in the structure of the formatting, and it's going to know how to convert that to an Oracle date, which in this case would be 04-JUL-05. And you can see a sample at the top of what that might look like when you call that function. Dates can also support the rounding and truncate functions, just like we did with numbers. You can do the same thing with dates, but instead of passing the position, you pass where you want to round to. So for example, if I wanted to round to the nearest year, you pass the round function a year. And so, for example, if if the date was 04/15/2012, actually that should be in the correct format. Sorry, it should be 15-APR-2012. If you round that to the nearest year, it just gives you the first date of that year, 01 January 2012. So regular expressions are interesting. I could probably give you an entire presentation on regular expressions. Actually, I could probably give you 5 presentations on regular expressions. They could be extremely complex, and they're very difficult to kind of wrap your head around if you've never done them before. So I'll give you the sense of what a regular expression is and how they're used. And then I'll give you some shortcuts on how to actually work with regular expressions if you've never used them before. If you know what regular expressions are, that's great. You can use them in Oracle, and this should give you enough information to put regular expressions to work for you. But so here's the concept. Take a look at this chunk of text that you see on my screen, this blob of text. Let's say I wanted to find all the emails in that text. The emails have a certain pattern to them. So there's a certain pattern, and the things that we can find in that pattern are things like @ symbols. So we know that all the email addresses are going to have an @ symbol. We also know that there's going to be a period or a dot. So I've highlighted all the dots here. Now, of course, there are @ symbols and dots that are not part of email addresses. So another part of that pattern is, no space before and after the @ symbol, and no spaces before and after a period somewhere in a contiguous block of characters. So we can define that pattern that we would be looking for to find an email address. And that's what regular expressions are all about. It's telling it's a function that basically says, well, what's the pattern that I should look for? What's the pattern I want to identify? And you could do this in theory with substrings and string functions, and it would be extremely complicated. But in theory, you could use a complicated, burrito I call it a function burrito of a whole bunch of string functions to try to find email addresses. And you could get pretty close, but regular expressions are really powerful because it lets us do it in one line. So, for example, this might select all the records from a table where the descript field, which might contain this long block of text, contains any email addresses. So as long as there's at least one email address, and it's not really, we're not telling Oracle find something that contains an email address. We're saying find me something that has this pattern, something that has letters plus an @ symbol plus more letters plus a period and then a couple more letters. And you could get even more specific. You could say there has to be at least 2 letters after the last dot. There has to be at least 2 letters before the dot. There can't be certain characters. So you can define all that stuff with regular expressions. Regular expressions is really pattern matching. That's what it is. So if you distill this all down, regular expression is looking for patterns. So as long as it finds this pattern, which is typically an email, it's going to return this record for you. And that's the regexp _ like function. There's another function, which is regexp _ substring, which basically says return me only the things in the string that match this pattern. So when it returns the record, instead of giving you this whole blob of text, it's only going to give you the email addresses that it finds, or rather only things that match that pattern. So anything that matches that pattern will display in our result set. Your book gives you a quick tutorial on regular expressions. I'm not going to test you on regular expressions. I think you would find that the Oracle test would have a few questions perhaps on regular expressions from a basic level. If you really want to learn regular expressions, there are lots of ways to do that on the internet. And if you like, I'd be happy to make a presentation that explains, or at least gives you a tutorial on how to start using regular expressions. In the meantime, most of us, when we have to use regular expressions, even if you know how to use regular expressions, somebody probably has already done the work for you for most patterns. For a lot of common patterns that we look for, there are libraries on the internet where you can look up regular expressions that you can use for patterns. So if you go and look up email, there's tons of different ones, and they'll tell you what the different rule sets are. Some of them are very basic, like you see here. Some of them get very intricate and implement all of the various rules with email addresses. So there's lots of options to find these regular expressions. There's a really cool program called regexbuddy that I use sometimes when I have to work with regular expressions. I think it costs $35, but if you do a lot of regex, it's well worth it. But you can basically write patterns, and it will write a regular expression for you, or at least validate for you that the one that you wrote will work on different things that you can pass into it. So some options there with regular expressions, and I think a lot of us just use there are some people that are just really good at regular expressions and write some pretty elegant ones. But like I said, I could teach a whole class on regular expressions. So finally, we're going to talk about some other functions. I'm just going to very briefly go over some of these. The ones in the book that they talk about, the one that I use the most is probably the ones that deal with null values. So, for example, if you take a look at my example here, if I do select null plus 2, so if I add a null to 2, my output is going to be null. It's going to be nothing. So anytime you multiply or subtract or add or divide a null into anything, you end up with another null. So, and this is important this is going to be more important when we talk about aggregate functions in a later section. But for right now, just understand that if you have a null value, it's going to ruin your day if you're doing any math. So to get around that, we can use a function called NVL. And with NVL, you basically you pass a value into NVL in the first position, and then you pass a substitution string in the second position. So excuse me. So in this case, null value, the NVL function, if it sees a null value, it's going to use the replace character. It's going to return the replace character. In this case, is 0. And if it's not null, it returns whatever you passed in. So if it happens to be a number 5, it'll return a number 5. But if it happens to be null, it returns a 0. So now this effectively, what I'm showing you on the screen, is going to treat null as 0. And this is probably the most common thing. I think most of us intuitively would think that null is 0. That null is 0 because it's nothing. But 0 isn't, null isn't really a 0. It's really the absence of anything. Boy, we could have a really interesting discussion about that. But this isn't a philosophy class, so let's concentrate on the fact that null is just the absence of any data. It's not a 0. It's not an anything. So we have to tell Oracle how to handle that. In this case, we're saying if it's not null, pass whatever is in there, but if it is null, use a 0 instead, so that we get what we want, which is 0 plus 2 equals 2. And there's a whole bunch of other functions that deal with nulls. There's null if. Null if is kind of weird. I honestly very rarely use null if, but it basically it's a way of telling Oracle what to do if two values are both null to do something, and if they're not null, then do something else. toChar is the opposite of toDate, which we talked about. I probably don't have to go into this too much detail. It's basically the polar opposite of toDate. So with the toDate function, we had an unformatted date that we wanted to convert to an Oracle date, but with the toChar function, we're taking an Oracle date and we're using the same format mnemonics that I talked about earlier, but we're telling Oracle convert the date to that format. So make it something more human readable, something like July, 4 space 2012 or whatever it was. Decode is a way of mapping contiguous characters to another set of contiguous characters. So you can map NJ to New Jersey and SC to South Carolina and PA to Pennsylvania, or PHL to Philadelphia and EWR to Newark and JFK to John F. Kennedy Airport. Something like that, where you're mapping values. So that's one way to do that. You can also do that with the case function. So you can use case. Your book has a really good example on using case. I think it's pretty obvious how it works when you look in the book. I don't really use case very often in a select clause. We're going to talk a lot more about using things like decode and case in the next semester when we talk about functions in much more detail. You could use them in the select clause, but for me, if I find myself using things like decode and case in a select clause, I'm usually considering just moving that all to a function, which again, or a procedure, which we're going to talk about in the next semester. There's also one more. This is an interesting one. This is kind of unique to Oracle and MySQL, but they have a soundX function, which I always think of it as a homonym. You can pass it a word, and it will find any other records that have that word, have the same sound of that word. I think your book uses the example of Smith. Let's say they tell you their last name is S-M-Y-T-H, but in the database it's S-M-I-T-H. They both sound exactly the same. So Soundex would find both the Smiths with a Y and the Smiths with an I. So it's useful for things like name lookup, especially when names are, you know what it sounds like, but you don't know what it looks like. You don't know how it's actually spelled. With words, not so useful because we all know how words are supposed to be spelled. Though I guess if there's a data entry error, certainly Soundex could be useful. But I think Soundex is useful for names. For the discussion topic, one thing you could discuss is a use for the Soundex function other than names. What's another scenario where you would be selecting something where you may not know the spelling, but you know what it sounds like? Other than just basic misspellings on words that should have been spelled right, what are some other examples that you can think of where that might get used? And that's basically it for functions.